Okay, question 5. This is the one which caused the most difficulty by a long way. I can see why. You're not given a diagram. It's all in terms of x, so it involves algebraic manipulation, and it involves a key problem-solving skill. So what I'd like you to do is to definitely not try to squeeze it in here, the correction. On the next available page in your book, can you put in correction for question 5? Unless you want to skip to the end. If you've done work and you want to see whether it's correct first, skip to the end of this video, where there's the improvement question, which I'd like you to do whether you got this correct or not. So correction for question 5. First thing, let's draw a diagram of this situation. So I've drawn this little symbol in here to show that there's a video for it. So if you're going back over your notes when you're revising for your assessment, you can have another look at this video to remind yourself. So that's useful. And please do it in green pen. I'm doing it in black so it shows up better on the video. So I've got an isosceles right angle triangle. So those sides are the same, and the hypotenuse is x centimeters long. Work out the area. So I think the key leap is to model these sides using a different piece of algebra. So I'm just going to call them A. If that one's A, this must also be A. Okay? So my first tip is to draw a diagram. That's the first thing you should do when trying to answer this question. The second thing is, can you model? Ask yourself the question, can I model with algebra? Can I find a way of, considering some of these sides and putting in some algebra? So I have done that. Now, it's a right angle triangle. It's going to involve Pythagoras. Either going to be involving trigonometry or Pythagoras. And if I want to find a side length, it's usually going to be, and I haven't got any angles to work with, it's usually going to be Pythagoras. So I'm going to use Pythagoras here. So the square of my two shorter sides gives me the square of my longer side. So what I've got here is the square root of A plus the square of another A is equal to the square of my hypotenuse. And that's, as soon as I've got that step, I'm really into this problem. So that's my first step. So let's just simplify that. A squared plus A squared is 2A squared. Okay. Right, I'm getting somewhere. Now, I want to try to express A in terms of x. So I'm going to manipulate this so I get A in terms of x. So first thing I'm going to do is, well, I'm going to just firstly square root it. So I've just got x. So I mean, I could divide both by 2. That would also work. Either way around is going to work. But actually, what I'm going to do to start with is I'm going to take the square root. Now, it's really important when I'm taking the square root here. X squared, the square root of that is just x. A squared, when I square root it, I get A, but I also have to square root the 2, so I get the square root of 2 times by A. Right? Both parts here have been, my coefficient has been rooted, and my variable A here has been rooted. So I've got root 2A equals x. And if I divide by root 2 on both sides, I've completed my job of expressing A in terms of x. So A equals x over root 2. Okay, and that's the key thing, because I now know what A is in terms of x. So I know my area is base times height divided by 2. So this is my base and my height. So my area here is x over root 2 times x over root 2 divided by 2. Okay, so my area here is x times x is x squared, root 2 times root 2 is 2, and that's all divided by 2. So if I've got something divided by 2, and then I divide it by 2 again, it's the same as it being divided by 4. So my area here is x squared over 4, and that's my answer. So full correction for question 5, and then I want you to have a go at this improvement question, which I'm going to set just kind of on a similar theme, where you have to, I'll give you the diagram, but you need to model it with algebra correctly, and then work it out. So, improvement question for question 5. Not to scale. A parallelogram is made of 4 right-angled triangles with hypotenuse x and one side which is 3/5 x. So each triangle has hypotenuse x and one of its sides is 3/5 x. And all you need to do is work out the area of the parallelogram in terms of x. Please copy this question neatly and complete showing all working. Thank you.